Pluto is one of the most mysterious and remote dwarf planets in the solar system. While a spacecraft has already visited it, it is very unlikely that humanity will ever manage to set foot on its icy surface. But why? Why is that a small unmanned probe like New Horizons could reach Pluto, but a spacecraft with astronauts couldn't achieve that with current technology? We'll find out why we could send all the space exploration probes we wanted to Pluto, but we could never send a spacecraft with astronauts to this icy world. Let's get started. I used to feel behind on business books. Everyone quoting lessons I didn't have time to read. That changed when I found Shortform. It's not the usual surface-level summaries. These guides break down every chapter, highlight key insights, and even compare what different authors think about the same topic. It's like a cheat code for entrepreneurs. I flew through the Lean Startup in one evening and came away with lessons I could actually use the next day. Even better, Shortform tied it to 0 to 1, so I could see two totally different takes on startups. If you're building something and want the best ideas fast, this is for you. Try Shortform at shortform.com/insane. You'll get a free trial plus 3 months off when you sign up for the annual plan. The New Horizons journey. On January 19, 2006, humanity reached a new milestone in space exploration. We launched a spacecraft with a single objective: to reach the last known corner of the solar system, the dwarf planet Pluto. This ship was the legendary New Horizons. It is, to this day, the only mission that has reached that distant world. But what was so special about it? What allowed this tiny probe to travel more than 3 billion miles from Earth and give us the most detailed images we've ever seen of Pluto? New Horizons was launched from Cape Canaveral aboard an Atlas V rocket. Its total mass, including fuel and scientific equipment, was a mere 1,054 pounds. They made it extraordinarily light, which was a key advantage. The lighter the weight, the greater the acceleration and the less thrust required to reach high speeds. In terms of speeds, New Horizons achieved something astounding. It left Earth traveling at approximately 36,000 miles per hour. In fact, it was the fastest spacecraft ever launched from Earth. In just 9 hours, it passed the orbit of the Moon, something that took the Apollo missions more than 3 days. And this journey was direct, without unnecessary turns or pauses. This efficiency was possible because it did not transport any humans, nor did it need to return. It just had to go past Pluto, photograph it, and continue on to the Kuiper Belt. One of the most critical factors in this mission was its power source. New Horizons doesn't run on solar panels. Pluto is too far from the Sun for solar panels to be viable at those distances. Instead, it utilizes a radioisotope thermoelectric generator, an RTG, a device that converts the heat generated by the decay of plutonium-238 into electricity. Thanks to this, the probe can operate for decades without requiring refills or maintenance. And how long did it take to arrive? New Horizons flew for 9.5 years through the vacuum of space before coming face-to-face with Pluto on July 14, 2015. At the time, the spacecraft was 3 billion miles from Earth. The flyby lasted only a few hours, but it was enough to revolutionize our understanding of Pluto completely. We discovered glaciers, icy mountains, a tenuous atmosphere, and a geological complexity that no one had expected on such a small and distant world. And the most incredible thing is that it did it all without stopping. New Horizons did not land or orbit Pluto. Its mission was a high-speed flyby. It assessed, photographed, measured, and continued its way to the Kuiper Belt, where it continues to send data to this day. But then, if this small probe managed to get this far, why can't a human crewed spacecraft do the same? New Horizons versus manned spacecraft. The difference between the New Horizons and a human crewed spacecraft is like the difference between a lightweight racing bike and a war tank. Both can move and carry technology, but they are designed for entirely different tasks. To understand why humans cannot be sent to Pluto as easily as robotic probes, we need to examine their fundamental differences in size, weight, structure, and requirements. New Horizons, as we have already seen, weighed only 1,054 pounds. It had no bathroom, no pressurized cabin, no heat shield, and no life support systems. It didn't need food, water, or radiation protection. It did not require air or water purification systems, nor did it have to concern itself with the physical or mental health of a crew during years of travel. Its interior was compact, optimized to survive in extreme conditions without human intervention. This made it fast, efficient, and cheap. Now imagine a human-crewed spacecraft capable of transporting 4 astronauts to Pluto. For starters, it would have to be at least the size of the Apollo capsules, or even larger than the Dragon capsules currently used by SpaceX. However, the first problem is that those spacecrafts are designed for short missions, typically lasting a few days or weeks. A mission to Pluto would last, as we will see later, between 15 and 25 years one way only. No current spacecraft is designed to withstand such an extended mission. A human-crewed capsule would require a spacious, pressurized habitat capable of maintaining oxygen, removing carbon dioxide, regulating temperature, providing food and water for extended periods, and shielding astronauts from cosmic radiation. It would have to carry multiple shields of protection, redundant navigation, power, life support, and most complex of all, some kind of artificial gravity system or extreme countermeasures to prevent the loss of bone and muscle mass during prolonged microgravity. To this must be added the weight of supplies. A single astronaut needs about 5,000 pounds of food, water, and oxygen to survive a year in space. 4 astronauts on a 20-year mission would require more than 400,000 pounds of supplies, excluding habitat mass, scientific equipment, communication systems, and fuel. Additionally, there is a little discussed crucial aspect: morale and mental health. Living locked up in a small space for decades, knowing that there is no return in the near future and no possibility of rescue, can have devastating effects on the human psyche. Missions to the International Space Station, the ISS, already require extreme psychological preparation for just a 6-month stay. Currently, no type of training adequately prepares an astronaut for a prolonged stay of several years or decades in space. So, while New Horizons is like a supersonic bullet that shoots into the void without worrying about what it leaves behind, a human-crewed ship would have to be a true, self-sufficient ecosystem, a miniature city with everything necessary to keep its occupants alive and sane for 2 decades. And all of that comes at a price: mass. A lot of mass. And in space, the more mass you have, the slower you travel and the more fuel you need. That is the real problem. Hey Curious Squad, before moving on, be sure to subscribe to our channel, clicking on the notification bell, and leave us a thumbs up so you don't miss out on our daily videos. Our greatest enemy: the time. Travel time is undoubtedly one of the biggest obstacles to any attempt to send humans to Pluto. While the New Horizons probe took 9.5 years to arrive, a human-crewed spacecraft would take significantly longer. And that's not just a guess. It's a direct consequence of physics and engineering today. To begin, let's recall that New Horizons traveled at an initial speed of over 36,000 miles per hour, making it the fastest object ever launched from Earth. That speed was made possible by 3 key factors: its low weight, Jupiter's gravitational assist, and most importantly, that it didn't have to brake when it reached Pluto. The spacecraft simply launched, sped past Pluto, and continued on its way. It did not have to slow down to enter orbit, much less to land. But if we wanted to send a human-crewed spacecraft to Pluto, the rules would change entirely. We can't just launch 4 humans through the solar system without braking. The spacecraft would have to decelerate to enter orbit around Pluto, or even land, and then have to have the ability to take off again to return to Earth. That means twice the fuel, twice the energy, twice the complexity. Now, let's consider the weight. If a spacecraft like New Horizons weighed 1,000 pounds, a human-crewed spacecraft capable of sustaining life for 20 years would easily weigh 1 million pounds or more. And moving that colossus through deep space would require an amount of energy that we simply don't currently have. With today's chemical rockets, a human-crewed mission to Pluto would likely take 15 to 25 years to arrive, depending on the route, initial velocity, and the number of gravitational assists used. And that's just the one-way trip. You also have to consider the time it would take to explore Pluto, repair the spacecraft, collect samples, and then make the return trip. In total, a round-trip mission could last more than 50 years. Can you imagine taking off from Earth at the age of 30 and returning when you are over 80? Astronauts who venture on that mission would not even have the physical condition to undertake the return trip. And let's not forget the communication factor. At a distance from Pluto, it takes about 4 to 6 hours for a radio signal to go back and forth from Earth. That means the crew should be able to resolve any emergency without immediate assistance from mission control. The astronauts would be completely alone. While an uncrewed ship can launch like an arrow, a ship with humans has to carefully plan its route, conserve resources, slow down, keep the crew alive, and, of course, come back. But suppose some deranged millionaire had the resources, both economic and technological, and voluntary to make this trip. What could they do to reduce travel time as much as possible? Gravitational assist, our own ally. Gravitational assist has been one of the most powerful tools we've used to explore the solar system. Thanks to this ingenious orbital trick, spacecraft such as New Horizons, Voyager, Pioneer, and even Cassini have been able to accelerate, change direction, and reach impressive speeds without needing to carry vast amounts of fuel. Could our astronauts use the same technique to get to Pluto? First, let's remember what a gravitational assist is. It is a maneuver in which a spacecraft approaches a planet to take advantage of its gravity, much like a slingshot. The spacecraft enters the planet's gravitational zone of influence, lets itself fall towards it, and when it exits, the relative speed between the two translates into additional momentum. No fuel is used, but a carefully calculated trajectory is needed to maximize thrust without falling into the planet or shooting off in the wrong direction. New Horizons, for example, used a crucial gravitational assist from Jupiter in 2007. Thanks to that maneuver, it gained about 9,000 extra miles per hour and reduced its travel time to Pluto by nearly 3 years. Without Jupiter, it would have taken about 12 years instead of 9. And here comes the problem for a human-crewed spacecraft: Jupiter's radiation belts. Jupiter is surrounded by one of the strongest magnetic fields in the solar system. This field traps high-energy particles, forming radiation belts far more powerful than Earth's. An uncrewed spacecraft, such as New Horizons, can pass through these regions without consequence, as its electronics are shielded from the radiation. In the worst case, only some systems will be shut down, but the ship will continue to function. Human beings don't have that option. Radiation levels near Jupiter can exceed 10,000 rad per hour in some regions. To put it in perspective, a dose of as little as 1,000 rad for a couple of hours is enough to kill a human being. A spacecraft attempting a near-Jupiter gravitational assist would have to be equipped with shields that protect the crew from radiation, further increasing its weight. One option would be to design trajectories that partially utilize the gravity of planets such as Venus or Mars, where radiation levels are less intense. One could even plan a distant trajectory around Jupiter, far enough away to avoid radiation belts, but still providing some momentum. However, these maneuvers would be much less efficient than those used by automatic probes. Also, for a gravitational assist to work, you have to wait until the planet is in the correct position, which means that the launch window can only open every few years. Robotic ships can wait for the exact moment without problems. Still, a human-crewed ship with humans on board who have limited resources cannot wait indefinitely until the planets are in position. So even with the technology we currently have, a manned trip to Pluto is not possible. What would we need to achieve it? Technology for interplanetary travel. If we ever dream of sending humans to Pluto, we must understand that the dream cannot be built with current technology. To achieve this, we would need to reinvent the way we conceive of space travel completely. We're not simply talking about bigger rockets or tougher capsules. We're talking about a new kind of spacecraft with revolutionary propulsion systems, self-sustaining structures, and shielding against threats we don't even face in Earth orbit. So what would it really take for a human-crewed spacecraft to reach Pluto? The first thing would be the size and structure. Such a craft could not be a simple capsule like those used in SpaceX's Apollo or Dragon missions. We would be discussing a mobile space station with a pressurized habitat large enough to comfortably house a crew of at least 4 astronauts for over 20 years. This would include spaces for sleeping, eating, training, doing science, and most importantly, maintaining physical and mental health in an enclosed environment. The habitable volume should be, at minimum, similar to that of the International Space Station, which is about 32,000 cubic feet. Then comes propulsion. Conventional chemical engines are simply not viable. They require enormous amounts of fuel and offer very low thrust for long trips. A realistic alternative would be nuclear propulsion, specifically thermonuclear propulsion, or even the more ambitious nuclear pulse propulsion, a technology proposed since the 1960s. This system would use controlled explosions of nuclear material behind the spacecraft to generate thrust. Although it sounds like science fiction, it is one of the few methods that utilizes existing technology that could significantly reduce travel time to Pluto, potentially reducing it from 20 years to less than 10. Comprehensive recycling systems would also need to be incorporated. You can't carry food and water for 2 decades, so the ship would have to recycle 100% of its resources: oxygen, water, nutrients. A closed ecosystem, such as the Biosphere 2 experiments, would be the basis for keeping astronauts alive for such a long time. In terms of energy, solar panels would be ruled out beyond Mars. The ship would need compact nuclear reactors to generate electricity steadily for decades. These reactors could also power electromagnetic shields or advanced composite materials to protect the crew from cosmic radiation and solar events. In addition, such a spacecraft would have to rely on the gravitational assistance of the inner planets, but with more precise trajectories and avoidance of radiation zones. It would likely include autonomous navigation systems, as signals from Earth would take hours to arrive, and the crew would have to solve emergencies without outside help. New Horizons showed us that even the most distant worlds can be reached. Its silent journey to Pluto was more than a technological feat, it was a message of hope. It showed us that although we cannot send astronauts to those icy confines today, one day we will. Because every image it sent, every piece of information it transmitted, was a reminder of what we are capable of achieving and how far we are willing to go. Pluto may be an unreachable world today, but did you know that it could be humanity's last refuge when the sun becomes a red giant? If you'd like to know why, check out this video.